So welcome to chapter 22. This is the last chapter in unit 5. What we've been working on so far in chapter 21 is all the hypothesis testing has been when we have one group or one, the example we did yesterday was with the ACT or the AP stats testing. But it was only one group and we were comparing it to the College Board proportion. Well, oftentimes we want to actually compare two proportions. We want to know if one group has the placebo and the other group has the real medication or the real treatment, whatever it is. We want to know how do the two groups do when compared to each other. So because we're talking about two groups and comparing them to each other, we need to talk about how to compare two proportions. Okay. So first of all, we have to have new formulas that deal with actually having two proportions. So the first one we're going to look at is the standard deviation of the sampling distribution model for the difference between two proportions. So remember from the chapter that we learned on random variables, we can't add standard deviations. Okay, we can only deal with variances, and we never subtract them. We add them together, and then we take the square root of them. So that's from the random variables chapter. So here are your formulas. Okay, the first thing I should say before we write down the formulas is we are going to the assumption is the wrong word, but we need to, when we're observing different proportions in independent random samples, we have to know that they are independent. So we can add their variances because, again, from that chapter on random variables, this did not work if the two different proportions were not independent. So they have to be independent. And we are dealing with independent random samples, so they will be independent. Okay, so here's your standard deviation formula. So we have the differences in the p hat. Remember that the p hat is for the sample. That's the sample statistic because we're trying to figure out where is the true proportion. Okay, so this is the sample. And then we have P1 times Q1. Q1 is 1 minus P1 over N1. And then to that we add P2, Q2 over N2. Okay. The standard error, and I know I haven't stressed the differences between these two very much. The standard deviation is going to be from the mean. Where is the population? How far away from the mean is the population? With the standard error, we're looking at within the sample, how far away from the mean is the sample that we're looking at. So the standard error, one of the other videos I talked about, that really means the variability, okay, because it's really not an error, but it's just how off of the mean are we. Okay, so that's why you have the p hats here with the standard error. Okay, so this would be a great time to pause the video in case you haven't gotten those written down yet. Okay, we still have our assumptions and conditions. These do not go away. We need to make sure with the randomization condition that the people for the group were drawn independently and at random from a homogeneous population. So from one type of population, we can't combine, if we're looking at Americans, we can't have Americans and people from Europe together. So we're only looking at people from America if that was the case. Okay. Also, those groups could be generated by a randomized comparative experiment. So as long as we're randomizing it, then that satisfies this assumption or this condition. The 10% condition, same as it was before. I guess the difference here is that we're making sure that the data are sampled without replacement. And so we're not having one person be even parts of two different groups, and we're not putting that person back in the group or once they're sampled. Okay, so it should not exceed 10% of the population. Okay, and the independent groups assumption, the two groups we're comparing must be independent of each other. And then the last one is the sample size. So still looking at the success and failure. So you must show that both groups or each of the groups are large enough, that each of the groups are above 10 successes and 10 failures. Okay, so For large enough samples, each of our proportions has approximately a normal sampling distribution, and the same is true with their difference. Okay, so we're going to be looking at this and making the assumption, or I guess if we sample big enough, we are going to have a normal curve to our sampling distribution. Okay. Provided that all of these things are true, as we talked about before, then the normal model is how it fits in, or the data will fit into a normal model. Okay, so the mean is going to be the difference in the proportions. The mean is the difference between those, and the standard deviation with the sampling distribution is the same as we talked about before. Okay, so for our confidence interval, so it's called a 2-proportion Z interval because we're using our Z, our critical value, and we have 2 proportions. So when those conditions are met, then we can go ahead and find the confidence interval. So here is the difference in with P1 and P2. Here's our Z-score, nothing that is not different, and the standard error is the difference in the, it's right here. The standard error is the difference with P hat, Q hat over N1, P hat 2, Q hat 2 over N2. Okay, and same as before, the critical value depends on the confidence interval that you choose. Okay. All right, so when we're talking about hypothesis testing, we want to group our proportions or our samples together. The null hypothesis is typically going to be that the difference between them is 0. I have also seen it written as P1 equals P2. In fact, I think I wrote it this way in my dissertation, that I had the means equal to each other. Okay, because then that was showing that there's no difference. So you could write it either one of these ways. It means the same thing. Okay, you're just saying that there is no difference between them. All right, so because we're saying that there is no difference between the 2 proportions, then the standard deviations are the same. So the word for that is pooling. So we combine them together to one overall population. Okay, so the pooled proportion becomes the success of the one and the success of the other. This is how we're going to create the proportion over the total number of people who were involved. Okay. All right, so you're going to round the numbers. Only time you round values in the middle of a calculation, and that's just a very good habit. You don't want to round until the very end. So this is how we're going to come up with the proportion. We add the successes divided by adding up how many people were involved. And the same thing is true when we're finding the standard error. Okay, so we have the P hat Q hat over N, P hat Q hat over 2. And that's how we're going to find the standard error. Okay. So we want to compare the standard error with the standard deviation. The null hypothesis doesn't provide a standard deviation, so we use the standard error. Okay, so we use that it's pooled here, and we'll do plenty of examples of these. Okay, so the conditions for the Z-test, because now we're going to use now we're going to look at hypothesis testing. The Z-test, the 2-proportion Z-test. Here is our hypothesis. Okay, so I said either one of these is what we can use. So, and then we pool them to find the combined proportion. And here's where we're going to use the pooled value for the standard error. Okay, so this is a little bit different than we did before. And here's our statistic. Okay, so you should already have the standard error formula written down, and now the statistic. So we have the differences in the 2 proportions, minus 0, over what that standard error is. Okay, so we know that this statistic will follow a normal model because the conditions are met, the null hypothesis is true, and we go right ahead and that is the same as what we've done before. So you have to make sure that the samples are independent. So that's one part of your checklist that you have to do. You want to make sure that that the groups are random. How they're put in there are random. Okay. And we still causality, that hasn't come up in a while, but we still are not saying that one thing causes the other. Okay, and we'll talk about how to write the conclusion, so we aren't tempted to talk about causality. Okay, so we have looked at inferences for the difference in two proportions. Most important thing to remember is that the concepts and interpretations are the same. The only thing that's different here is that we have the two groups and we're comparing them to each other. The process of hypothesis testing is exactly the same. Okay. They're based on normal models, just as we have done before. We find the standard error of the difference in the two proportions, and you add the variances together, assuming the groups are independent, and then we test a hypothesis that the two proportions are equal. Okay. That is the end of the slides. We will go through many examples on the beginning of next week.